Good day once again, everyone. Today is another beautiful day, and I want to use this opportunity to welcome you to the Physics branch of Mathematics Solution Center. Today, we are going to be looking at a topic that says moment of a force. Under this topic, we are going to look at the definitions of a moment of a force, and we are going to solve various examples. What is moment of a force? We have two definitions for moment. Number one thing I want you to know based on this topic is that don't just say moment of a force, but say moment of a force about a point. Because the moment of a force about various points is not the same. I can have moment of force F1 about point A and about point B. So the moment of a force about a point is the turning effect of that force about that point. What am I trying to say? The moment of force F1 about point A is the turning effect of force F1 about point A, while the moment of force F1 about point B is the turning effect of force F1 about point B. Because the moment of force F1 about point A will never be the same as the moment of force F1 about point B. Why? Because they are not at the same distance from the line of action of F1. Therefore, this will lead us to the second definition of a moment. The second definition of moment is that the moment of a force about a point is the product of the force and the perpendicular distance from the line of action of that force to the point where moment is taking place. Okay, let me explain this further. Take, for instance, I have a distance from the line of action of F1. Let's call it x1. And I have another distance from where that ends to point B. So let's call that one x2. Therefore, the moment of force F1 about point A is going to be the what? Moment about point A of F1 about point A is going to be what? The product of force F1 and the perpendicular distance from the line of action of force F1 to the point where we are taking moment. Therefore, it's going to be what? F1 times x1. That is the moment of a force F1 about point A. The same thing, the moment of force F1 about point B is going to be what? The product of the force F1 and the perpendicular distance from the line of action of force F1 to the particular point where I am taking my moment. If you look at this diagram, the distance of the line of action of force F1 to point B is going to be what? X1 plus X2. Take note of this definition. It is very, very important. If not, you will just use anyhow distance that you are not supposed to use in solving problem under moment. And I understand that this is the basic problem that most students face while they are solving problems under moment of a force. So there's always distance, and the distance is from the what? From the point of line of action of that force to that particular point where we are taking moment. And I'm going to give an example, but I will advise you, after I have drawn the diagram, stop this video, try to solve it, try to solve the question, and then compare your answer with what I am going to do. Okay, in this diagram, we are going to calculate the moment of the force 2 Newton about point A, about point B, and about point C. So I want you to pause this video now and try this exercise and compare your answer with what I'm going to do. So question number 1, what is the moment of the force 2 Newton about point A? Okay, from the fact that what the moment of a force is equal to the what? The product of the force and the perpendicular distance from the line of action of this force to the point where I am taking my moment. I am taking my moment about point A. Therefore, the moment of the force 2 Newton is going to be equal to what? 2 Newton times what? 2 meter, because the distance from the line of action of my 2 Newton force to point A is 2 meter. Therefore, I am going to have what? 2 times 2. I am going to have 4 Newton meters. In case I have not told you the unit of a moment, force is in Newton, while distance is in meter, SI unit. Therefore, the unit of moment is what? Newton meter. So the moment of my force about point A is what? 4 Newton meter. Now we are going to calculate the moment of the force about point B. Moment about point B, the same force. We don't have another force. Take note of that. So the moment of the force about point B is going to be equal to what? The product of the force times the perpendicular distance from the line of action of that force to that particular point where I am taking my moment. I am taking my moment about point B, and my distance from the line of action of the force to the point where I'm taking moment is 4 meters. 2 plus 2. I get my 4 meters. Therefore, the moment of the force is going to be what? 2 times 4. Therefore, my answer is going to be what? 8 Newton meters. Okay. Number 3 is the moment of the force about point C. Moment about point C is still going to be the same thing. The product of the force times the perpendicular distance from the line of action of that force to the point where I am taking moment. Let's take a look at the diagram. This is the line of action of my force here. And the distance from that particular line of action to the point where I'm taking my moment is 2 meters. Therefore, the moment of my force is still what? The same thing as what? 4 Newton meters. My answer is what? 4 Newton meters. We've gotten the answer. Okay. Now we are going to the conditions for equilibrium under the action of parallel coplanar forces. This is the next thing we are looking at this particular stage. The conditions of what? Equilibrium under the action of parallel coplanar forces. What do we mean by coplanar? It means that the forces are acting on the same plane. Number one condition is under forces. Balancing of forces. The algebraic sum of all the forces acting in the horizontal direction must be equal to 0. What do we mean by this? It means the total forces acting towards the right hand side must also be equal to the total sum of forces acting towards the left hand side. The algebraic sum of all the forces acting in the vertical direction must be equal to 0. What do we mean by this? It means the sum of all the forces acting towards the upward direction must be equal to the sum of forces acting downward. And number two condition for a body to be in a state of equilibrium is that what? This body is not rotating. So from what we have here, it means that summation of the moment around this body must be equal to 0. That is, summation of all the clockwise moments must be equal to the summation of all the anti-clockwise moments. Take note of that. So we are going to start by solving examples on this. Examples. Okay. Actually, in this tutorial, we are not going to cover center of gravity. Center of gravity comes up in our next tutorial. Take note of that and watch out for it. Calculate the value of x for this system to be in a state of equilibrium. Now we are going to consider all the conditions of equilibrium, for parallel coplanar forces. Okay. There is no force acting towards the upward direction, and there is no force acting towards the left or the right hand side of the system. Therefore, the body is balanced in the horizontal direction already. The only forces we have is what? 5 Newton and 20 Newton. Okay, the only force that is acting towards the upward direction here is the reaction at the support. But the question is not asking us to calculate that. And that can easily be gotten if we represent the reaction at this support. If we decide to represent the reaction at the support by letter P, so that means our P will be equal to what? 5 Newton plus 20 Newton. Summation of all the forces acting downward must be equal to the summation of all the forces acting upward. That is just to say that the reaction at the support must be equal to the total force acting downward. Therefore, the reaction at the support is equal to what? 25 Newton. Take note of that. Okay, to find the value of x where this system is going to balance so that it will not rotate, we are going to make use of what? Summation of clockwise moment will be equal to what? Summation of all the anti-clockwise moment. So what is our clockwise moment? This is our support here. The support is where rotation is going to take place. Now, if rotation is going to take place here, what is the effect of this 5 Newton force? Now, let's take a look at this system. The 5 Newton is trying to bend the system, pull it down, okay? and keep it to rotate, it want to make it to rotate like this, you can see that this is a kind of what? Anti-clockwise movement. Anti-clockwise movement. Therefore, the moment as a result of the 5 Newton, it is what? Anti-clockwise what? Moment. Now look at the 20 Newton. It's trying to pull the system down so that rotation will take place at the support. Therefore, this will lead to what? A kind of what? Clockwise rotation. Clockwise rotation. So what this simply means is that the moment as a result of the 20 Newton force is what? Clockwise what? Moment. Clockwise moment. Now, and these are the two forces we have. Therefore, what is the moment of the force 5 Newton? It is the product of the force and the perpendicular distance from the line of action of that force to the point where rotation is going to take place. So the perpendicular distance from the line of action of 5 Newton to the point where rotation is going to take place is 10 meters. Therefore, I'm going to have what? 5 Newton times what? 10 meters. And this will be equal to what? 20 newtons times what? Esc. Okay, now we solve. 50 is equal to 20x. 50 over 20. 0 cancels 0. Then I'm going to have s is equal to 2.5 meters. This is the distance required to keep this body in a state of equilibrium in relation to the two forces 5 Newton and the 20 Newton. Okay, so you can see that the 5 Newton, the explanation here is that a 5 Newton force is able to balance a 20 Newton force. So that means that a small force can generate a higher moment when the distance is what? Is longer. So you can see that a 5 Newton force is able to produce the same turning effect as that of what? 20 Newton force. So that means the longer the distance, the greater the moment a force can generate. Therefore, with this, the advice is that you want to create a spanner. For the spanner to be more effective, you can make the arm of that spanner to be longer, because the longer the arm of the spanner, therefore the greater the what? The greater the turning effect this spanner will be able to create. Take note of that. Okay, the next question we are going to solve is what we have in our front end page. Okay, let's take a look at this question. A light beam AB sits on two pivots, C and D. A load of 10 newtons hangs at 2 meters from the support at C. Find the value of the reaction forces P and Q at C and D. Take the distances as shown. The question says the 10 Newton is located at a distance of 2 meters from the support C. Number one thing we are going to do is to apply our conditions of what? Equilibrium under the action of parallel coplanar forces. Number one is that what? Summation of all the forces acting in the vertical direction is equal to 0. Therefore, summation of all the upward forces. Where are the upward forces? We have the reaction at C, R, and the reaction Q. Will be equal to the only force acting downward is what? 10 newtons. Therefore, I have that what? P plus Q is equal to 10 newton. Equation 1. There is no force acting in the horizontal direction. Then the next thing I'm going to do is what? I will take moment about one of the supports. So taking moment about point C. So why taking moment about point C? It means that what? We assume that the only support that exists is the support at C. There is no support at D. Is that taken? But the reaction force is there. Okay, but before we go further, if I should take moment about point C, what will be the moment of an R? What will be the moment of R? Now let me quickly say this. I forgot to tell you this, that the moment of a force about a particular point its line of action passes through is 0, because there's no perpendicular distance away from the line of action of that force. Therefore, the moment of force R about what? Point C is actually what? 0, because there's no perpendicular distance. Take note of that. This means that my 10 Newton force want to go like this, want to bend the system around the pivot at C. Therefore, is creating what? A kind of a clockwise moment. Why my Q the force Q is trying to raise the system up like this so that it will rotate about what point C. Therefore, it's leading to what a kind of what anti-clockwise. Anti-clockwise moment. So that is all we have. The moment of the reaction R is equal to 0 because I am taking moment about a point its line of action passes through. There is no perpendicular distance. Condition for moment is that what? Summation of clockwise moment is equal to what? Summation of anti-clockwise moment. Therefore, the moment of the force 10 Newton is going to be equal to what? The product of the force times the perpendicular distance from the line of action of the force to the point where I am taking my movement, which is 2 meters. And the moment of the force Q is going to be equal to what? The product of the force Q and the perpendicular distance from the line of action of force Q to the point where I'm taking moment. That is 10 plus what? 2 meters. Therefore, I'm going to have 10 times 2, 20 is equal to Q times 12. Therefore, I have 12Q is equal to 20. I will divide both sides by 12. And I'm going to have what? Q is equal to 20 over 12. Q is equal to 1.67 Newton. That is the reaction force at point Q. Okay, I already have one equation which says that what? P plus Q will be equal to what? 10 newtons. If my Q is 1.6, P plus 1.67 is equal to what? 10 newtons. Therefore, subtract 1.67 from both sides. I have my P is equal to 10 minus 1.67. My P is equal to what? 8.33 newtons. Okay, that is that. But I'm going to retry this while taking moment at point D. And let's see if I am going to get what? My P to be equal to what? Is actually R. If I am taking moment about point D, it means that the moment of the 10 Newton force is coming down this way. Therefore, it is an anti-clockwise what? Moment created by it. The moment of Q will be equal to what? 0, because I am taking moment about a point its line of action passes through. Why the moment of force R? But I have taken my R to be P, maybe mistakenly, so it's going to be what? A kind of a clockwise moment. Please change your P to R to P. Take note of that. Okay, now let's go back to our question. The force that is going clockwise direction is my P. Then it's going to be what? The product of P and the perpendicular distance from the line of action of P to the point where moment is taking place. And is equal to what? The one that is going anti-clockwise is actually the 10 Newton. The product of the 10 Newton force times the perpendicular distance from the line of action of the force to the point where moment is taking place. 12P is equal to 100. Divide both sides by 12. My P is equal to 100 over 12. If there is no any form of mistake, I am supposed to get the same value as I have gotten before. 8.33 newtons. So we've gotten the value of our P to be the same thing as we've calculated before. In case you have any question, please don't forget to put it in the comment section. We are still coming up with other complex questions like the ones that include what? Center of gravity. Don't forget to what? Subscribe to this YouTube channel so that you will not be missing out when these videos will be coming up. Thanks and remain blessed.